Okay, this is your second lesson, the last one in the chapter. We're going to be combining this with chapter 2 for the test. So in last chapter or section, we talked about solving inequalities. So when you're greater than 0, we want to know when this equality is greater than 0. So if we solved like normal, we would say when x is greater than 12/7 or decimal, that's when we're greater than 0. In this section, we're going to be talking about quadratics. So these were linear functions. When you're raised to the second power, you're called a quadratic. Quad does mean 4, but quadris means square in Latin, so that's why it's squared. So when you solve quadratics, it's going to be very different than solving a linear equation. You have to do what's called factoring sometimes. So there were two quantities that when multiplied together would give you x squared minus 7x plus 12. So when we break it apart, okay, this is called, sorry, it's unfocused. This is called factoring a trinomial because there's 3 when a, or the number in front, is 1. So if you're trying to Google, like, okay, I need to learn how to factor better, this is factoring a trinomial when a equals 1. My students in high school called it unfoiling, which is totally not a word. When I say unfoiling, they get it, okay? So what numbers multiply to 12 that give you 7? We know 3 times 4 gives you 12. The order does not matter. It's the signs that matter. So a positive 4 times a positive 3 gives you 12. But when they add, they have to add up to negative 7 because when you FOIL, you're going to combine those like terms of 4x and 3x to get negative 7. So you need a negative 3 and a negative 4. There's a great video on YouTube that gives you hints. It's called Teach Me How to Factor. Okay, and what they do is they have this little wrap and it says if you have 3 terms with a plus in the back, this sign will double up like a Wendy's double stack. So if there's a plus in the back, you know it's going to be minus minus. If there's a plus in the back, you know it's going to be plus plus. There's no plus in the back here. So it's not plus plus or minus minus, it's going to be a plus minus. So let's practice factoring so that we're able to eventually solve. So here, yes, you could bring 9 to the other side and solve that way. And you'd say, okay, what squared gives you 9? Take the square root of both sides. Since you're solving, you need not only the principal or positive square root, but you need also the negative one too. Okay, so that's your answer, but you can unfoil. Not a real word. So you know it's going to be x and x. What 2 numbers multiply together give you negative 9? Well, one would have to be positive and one would have to be negative. Okay. Now here's the thing. There's a property called the zero product property. And the zero product property says that if you have a product or 2 things being multiplied to equal 0, you can set each piece or factor equal to 0 and solve, and that is your answer. Well, yeah, that's your answer. Your answer is 3 and negative 3. So same thing here. According to that video, it said we have 3 terms with a plus in the back. Our signs will double up like a Wendy's double stack, plus plus. Well, what are factors of 3? It can only be 3 and 1. Let's check it. X squared, yep. 1x, 3x is 4x, plus, yep, that works. So when we solve, we get negative 3 and negative 1. The beauty of math is that you can substitute your answers back into your equation to solve. If I substitute negative 3 in here, I get 9 minus 12 plus 3. So 9 plus 3 is 12. Negative, oh, yep, it equals 0. So you can check your work. That's why I like math so much. Here, do you have 3 terms with a plus in the back? No. So your signs will not double up. So one of your signs will be positive, one of your signs will be negative. Which one goes with which? We got to figure it out. Factors of 6 are 6 and 1. 6 and 1 will never give you a negative 1. Factors of 6 are 2 and 3. 2 and 3 can give you a 1. We want a negative 1. So the larger number's got to be negative. Yeah, x squared, negative 3x, positive 2x, negative 6. When you set each piece equal to 0 to solve, your answer is going to be negative 2, and your answer is going to be 3. Okay, but that's just simply solving. We're now solving. See, there's a lot of back information that you need to remember or know to solve this quadratic inequality. These are not inequalities. So here we have to factor to get what's called our 2 critical numbers. Okay, so this is kind of off to the side. This is saying my critical number now is going to be 4, and my critical number is going to be 3. And when I say critical numbers, these are numbers where intervals are created. Now we're solving with all algebra. In mathematics, we can graph these functions. Rene Descartes came up with the coordinate plane. Rene Descartes was like 1600s, and he came up with the x and y coordinate plane to graph these functions. Okay, so if I want to graph this equation, I just start plugging in numbers to get y values, or I could say, hey, here's some critical numbers. I know that a quadratic, every time I graph it, it's going to have this U-shaped curve called a parabola. Okay. Now, when I find the critical numbers, that means at 3 and 4, I will cross the x-axis. I know it's a U-shaped curve. We'll just make this 4 then. I know it's a U-shaped curve, and it's going to cross the x-axis. So what this is telling me is, when is it greater than 0? Well, if 0 is here, when is this quadratic greater than 0? Here and here. So any numbers that were less than 3, 2, 1, you had an answer up here. Any numbers that were greater than 4, 5, 6, 7. Any numbers in between 3 and 4 were less than 0, were greater than 0. So just looking at the graph itself, I could see my answer. My answer would be less than 3. It's also equal to, and greater than 4. That's your answer, you're done. Or you'd say from negative infinity to 3, union, meaning and. Like, think about it in Spanish class, the letter Y was and. Think of you as the same thing. Union means, together. So that's your answer. From all your negative numbers up to 3, and from 4 onward is your answer. But that's graphically solving. Your textbook doesn't teach you that method. That's okay. Algebraically, they want you to find it. So what you're going to do, so knowing all this, come back to your original equation. They want you to solve for this quadratic. To solve, you factor. To factor, you get your critical numbers, and then you have to test them. So there's going to be a little table in your book, and it says you're going to test from negative infinity to your smallest number, from your smallest number to your next greatest number, and then from your greatest number to infinity. And I'm putting brackets here because we're equal to, we're allowed to be those numbers. So test those numbers. If I pick a number in between 0 and 3 and substitute it in, will it work, is what they mean by testing it. So let's try a number between negative infinity and 3. Some people pick like 2 or 1. I say pick 0. 0 will clear things out, I'll make it clear. So if I plug in 0, I'm going to get 0 minus 0 plus 12. Is 12 greater than or equal to 0? Yep, so this interval worked. Now they want you to test this interval. What's a number between 3 and 4? 3.5. If I substitute 3.5 in here, will it be greater than 0? Okay, I'm going to tell you right now, it won't work. I'm going to plug in a number between 4 and infinity. Let's try the number 5. Sure. Or you could try 10, whatever's easiest. Let's try 10. I like 10 because, okay, 10 squared is 100. 100 minus 70 plus 12. Is that greater than 0? Is 30 plus 12 greater than 0? Is 42 greater than or equal to 0? Yes. So these two intervals worked. So see how that's a lot of substituting in and checking mathematically? I recommend doing that and doing this. Personally, I would look at this graph, write down the critical numbers, graph it, think about it logically, and then go back and check it algebraically when you're taking a test, okay? So these two are your answers. I understand that's a lot of work for one problem. That's why we're making 2 parts for one video because there's a lot to explain. So here we go. Let's try it again. I want to solve for this inequality. I recognize that it's a quadratic, so I'm going to factor. Do you have 3 terms with a plus in the back? No. So you're not going to have plus plus. You're not going to have minus minus. It's going to be plus minus. It's a negative in the back. Factors are 2 and 1. The larger number is going to be positive. So off to the side, my critical numbers are negative 2 and 1. That means these are going to be your intervals to test. You start with the smallest number, then the smallest number to the next greatest number, and then the greatest number to infinity. So these are all your intervals you have to check. I know it's a lot. So a number between negative infinity and negative 2. Let's try, you can pick any number. Why don't you try negative 3? Negative 3 squared is 9. Negative 3 times 1 is negative 3. And then there's negative 2. Is that less than 0? Is 4 less than 0? No, this is not going to work. And here's a hint. It usually alternates. So the next 2 intervals, it'll probably be yes, no. So let's try it. What's the number between negative 2 and 1? Let's try 0. If I put 0 in here, 0 plus 0 minus 2 is less than 0. Is negative 2 less than 0? Yep. 1 to infinity. Let's try the number 2. We can't use 1 because we have to be less than, not equal to. So let's try 2. 2 squared is 4. Plus 2 minus 2 is less than 0. Is 4 less than 0? No. So this is just your answer. Your answer is negative 2 to 1. If you were to graph it, let's check. Your critical numbers were negative 2 and positive 1. Now, when are you less than 0? Between negative 2 and 1. Done. Okay? Let's try one more for this types of functions. You have to bring the number to the other side if you want to factor. Make sure everything is to one side. Oops. Make sure everything is to one side. You have 3 terms with not a plus in the back. Your signs will not double up like a Wendy's double stack. Factors are 2 and 1. Okay. This is positive now. Oh, so I lied. When it moved to the other side, I apologize. It becomes positive. So your numbers will double up. It'll be negative, negative. Therefore, your critical numbers are 2 and 1 because you set each piece equal to 0 to solve. So let's look at it graphically. 1, 2. When are you greater than or equal to 0? Any number this way, any number this way. So your answer would be negative infinity to 2. I apologize, to 1 and 2 to infinity. And we actually touch those numbers, so they're brackets. But like I said, that's just like a visual quick way to do it. I didn't do that here. This is how exactly your book wants you to do it. This is just, here's my numbers, let's graphic, let's think about it logically. Now let's try it algebraically. Does a number between negative infinity and 1 work? Well, if we plug in 0, we can plug it in here or in here. 0, is 0 greater than or equal to negative 2? Yeah, it worked. All right, will this one work? What's a number between 2 and infinity? Let's try 3. If I plug in 3 here, I get 9 minus 9 is less than or equal to -2. Is 0 greater than or equal to -2? Yes. So my answer is correct. All right, this is part 1 of the videos. Look to see part 2.